This is the second class of the coordinate geometry. Here we will learn the distance formula and we will solve some previous year questions. In the previous class, what we studied, just we will recapitulate. One thing is the distance of a point from a line. Suppose you are taking a point here and suppose a line is here, then the distance of the point P from the line L is the perpendicular distance. Here it is 3 units. If you will see, this is 3 units. We cannot take the distance like this one or this one. We cannot take these lines. Distance means shortest distance. You remember this always. Distance means shortest distance, or that is equal to perpendicular distance. Perpendicular distance. Similarly, if you take any point, suppose someone is asking the point, let this is minus x is equal to minus 6 and y is equal to minus 5. What is the distance of this point from the x-axis? Then you will draw a perpendicular from the point to the line, and this distance will be this perpendicular distance will be the distance of the point from the line, and this distance will be equal to now 5 units, like this. That we read in the last class. Now we will read distance between two points. Suppose one point is P here, this is point P, this is point Q, and the distance between these 2 points P and Q is same as the length PQ. PQ is the distance between point P and point Q. Point P is having coordinate x1, y1. That means this point will be equal to x1 and this point will be equal to y1. Similarly, this point will be x2 for point Q2. For point Q, it is x2 and this is y2. If you will see, this is y2. Now, if now we will derive the distance formula, that means we will find the length. We will calculate the length PQ. You see, the length of PR is equal to, if we will see, PR length is equal to UR minus UP. That is same as UR. If you will see, this is same as OT. This is same as this one, you see, and that is equal to x2. From this point to this point is x2, so also from this point to this point is x2. Minus UP is x1. So PR is equal to x2 minus x1. That means this length is x2 minus x1. Similarly, if we will go to calculate QR, then QR is equal to, if you will find QR, this is equal to QT minus TR, and QT, if you will see, it is equal to Y2. Similarly, TR, if you will see, it is x1. So it is y1. TR is same as y1. TQ is same as Y2 from this to this length, and your TR is same as OU, that is equal to Y1. So QR is equal to Y2 minus Y1. This is Y2 minus Y1. Now we can find PQ, because PQR is a right angle triangle. So PQ we will get PQ square is equal to PR square plus QR square, and PR we already got it as x2 minus x1 whole square plus QR is y2 minus y1 whole square. So length of PQ is equal to x2 minus x1 whole square plus y2 minus y1 whole square square root. This is nothing but same as the distance D. So this is the distance formula. D is equal to x2 minus x1 whole square plus y2 minus y1 whole square square root. You have to remember this formula, and distance is always positive, where x1 y1 is one point and x2 y2 is the another point, and D is the distance between them. Now we have to solve the first question. The distance of point P1 minus 1 from x-axis, 1 minus 1, x is equal to 1, y is equal to minus 1 is this point, you see. And distance of this point from x-axis, now this line is this one, x-axis is this line. And we know the perpendicular distance is the distance of the point from the line. Hence, distance D is equal to 1. Also, we can calculate it by distance formula. If we will take this point is having coordinate x is equal to 1 and y is equal to minus 1. But this point, if you will see, here x is equal to 1, and on x-axis we have already told that y is equal to 0. So distance D, suppose this is the distance D, we will calculate D is equal to 1 minus 1 x2 minus x1 whole square. This is x2 y2, this is x1 y1 plus 0 minus of minus 1 whole square, or that is equal to, this is equal to D square, or D is equal to square root of this 0 square plus 1 square, that is equal to 1. So D will be equal to square root of 1, which is equal to 1 unit. This is same as the perpendicular distance here. Now, first question we will solve. This is the previous year question. Prove that the points 3, 0, 6, 4 and minus 1, 3 are the vertices of an isosceles triangle. We will solve it. Let point A is 3, 0, point B is 6, 4 and point C is minus 1, 3. You can draw a triangle also. This point let be A, this point is B, this point is C. So now you will calculate the distance. Suppose we are calculating AB. When we will calculate AB, that means here in case of this is x1 y1 and this is x2 y2. So we can write now x2 minus x1 whole square. This is x1 y1 and this is x2 y2. So AB will be equal to x2 minus x1 whole square, that is 6 minus 3 whole square plus 4 minus 0 whole square square root, that is equal to 3 square plus 4 square square root, which is equal to 5. Similarly, when we will calculate BC, BC is equal to, we will take this as x1 y1, anything you can, x2 minus x1 whole square is same as x1 minus x2 whole square. Let it be x1 is let it be x3 and y3. So we will let x3 minus x2 whole square, that is minus 1 minus 6 whole square, plus y3 minus y2 whole square, 3 minus 4 whole square, square root, that is equal to 7 square plus minus 1 whole square, that is equal to plus 1 square root, that is equal to square root of 50, or we can write it as 5 into square root of root 2. You can take a x1 y1 up according to your convenience. Okay, you can take anything. You can take x1 y1 for a, x2 y2 for b, or you can take x1 y1 for b, point b, and x2 y2 for point a. You can write. Now we will calculate AC. AC will be equal to, if you will see, that is equal to minus 1 minus 3 whole square plus 3 minus 0 whole square, square root, that is equal to 4 square plus 3 square, square root, that is equal to 5. As AB is equal to AC, so triangle is isosceles. Next question is, if you will see here, you will take, if a point 0, 2 is equidistant from point 3p and p5, then find the value of p. You see, if a point A is here, suppose it is equidistant from point B and it is equidistant from point, let it be C. C is having coordinate p and 5, B is having coordinate 3 and p, and A is having coordinate 0 and 2. Equidistance means we have to prove AB is equal to AC. Now AB, if you will calculate, that is x2 minus x1 whole square plus y2 minus y1 whole square. You write it as AB square. So it will be equal to 9 plus p square minus 4p plus 4. Similarly, AC square will be equal to p minus 0 whole square plus 5 minus 2 whole square, that is equal to p square plus 9. We know that equidistance meaning given that AB is equal to AC. This implies AB square is equal to AC square, or we can write this as p square minus 4p plus 9 plus 4 is equal to p square plus 9. We can cancel 9 from both the sides. We will get p square also will be cancelled. We will get 4p. We will get 4p is equal to 4. This implies 4p is equal to 4. We write it 4p is equal to 4, or p is equal to 4 by 4, that is equal to 1. And okay, next question we will discuss later, next part.